45 million is 4.5 times 10 to the 7th power.
Watch the scene first. The math is built into the world, so the quantities can be seen before they are named. To record these extremely large and extremely small quantities, we use numbers expressed in the form a times 10 to the nth power. This is scientific notation. Within this structure, the leading factor a stays at least 1 and strictly less than 10. While animal action shows the scale of the environment, the notation records the exact relationship, anchoring the microscopic and the enormous to the same rules. To write the large quantity 45 million in scientific notation, we look for that leading factor. Moving the decimal 7 places creates a leading factor of 4.5. This satisfies our rule of being at least 1 and less than 10. Those 7 places correspond to a factor of 10 to the 7th power. 45 million equals 4.5 times 10 to the 7th. The same logic applies to the microscopic scale, like the quantity 0.000032. We move the decimal 5 places to the right to isolate the factor 3.2. Because the decimal moved to the right, the exponent is -5. We attach the factor 10 to the -5th. 0.000032 equals 3.2 times 10 to the -5th.
32 millions is 3.2 times 10 to the -5th power.
This structure allows us to compare values directly. To find about how many times as large 6.2 times 10 to the 8th is compared to 3.1 times 10 to the 5th, we look at the components separately. First, the coefficients. 6.2 divided by 3.1 equals 2. Then the powers of 10. 10 to the 8th divided by 10 to the 5th equals 10 to the 3rd. Combined, 2 times 10 to the 3rd gives us an estimate of 2,000. 6.2 times 10 to the 8th is about 2,000 times as large as 3.1 times 10 to the 5th. A cell is about 8 times 10 to the -6th meter wide, and a hair is about 8 times 10 to the -5th. How many times wider is the hair? Since the coefficients are both 8, their ratio is exactly 1. Subtracting the exponents, -5 minus -6, results in 10 to the 1st. The hair is about 10 times as wide as the cell. Every value in this environment is recorded by matching the animal action to the symbols on the surface. To maintain this structure, the leading factor always stays between 1 and 10. When estimating how much larger one quantity is than another, divide the coefficients and subtract the exponents. Looking at the scene, which marks prove the mathematical relationship, and how does the animal action make it true?
6.2 times 10 to the 8th divided by 3.1 times 10 to the 5th is 2,000.